What exactly do you do here? It's much more than what do you do when you sit in your cube or these days you sit at home. What exactly do you do? Product marketing is one of the most challenging areas of technology and startups. And how do you make sure that you can relate what you do to make it meaningful for somebody to listen to? I can tell you that if you want to find out how to do this, Noemi Greyzdorf knows how to get it done. And you are about to find out exactly how. So let's jump in. Welcome back to the DiscoPosse podcast. My name is Eric Wright, and if you love what you're seeing and you want to see more of this good stuff, make sure you do me a favor and you hit that subscribe. I always get that backwards. Hit the subscribe button. Is it there? I don't know. I add this in post. I hope I get on the right side. The point is, hit the subscribe button. And this is Noemi Grasdorf. She's the VP of Marketing at Vicinity. And not only are they solving a really fantastic, difficult challenge, besides diving into Vicinity, we learned about how to do effective product marketing and storytelling. Noemi has really an incredible story herself. So with that, let's just jump right in. This is Noemi Greyzdorf from Vicinity on the DiscoPosse podcast.
Hi, this is Noemi Greyzdorf. I'm VP of Marketing at Vicinity, and I'm joining DiscoPosse podcast today. I'm excited for the conversation with Eric. I came to Vicinity fairly recently, only about 4 months ago. It's an exciting technology. It's an exciting company to be at. And I look forward to sharing both how I got here as well as what we're doing.
Perfect. All right. And thank you, Noemi, for joining. This is neat because I'm often introduced to folks that are in a sort of relative sphere where we, at different areas in the industry, different areas in the organization. So I love that you've got a really cool background as to how you got to Vicinity. We'll
Mhm.
talk about Vicinity itself, which I think would be kind of neat for sharing with folks who are listening, and then we'll talk about what you're doing there, what's unique and neat about it, as well as, yeah, like you said, how you got there, which is kind of cool. So,
Sure,
uh,
sounds good.
if you want, let's do a quick do the elevator pitch, so to speak, on Vicinity and let people know what it is that the problem is you're tackling there.
Sure. So the challenge that we're tackling is, as I think it was Gartner who posted recently in one of their reports, that by 2025, 75% of all data being created in the enterprise is going to be at the edge. And what the edge means is that it's not in the data center. So there's two challenges there. One is we have had this ebb and flow in terms of centralization and decentralization, but predominantly key applications are still in the data center. So how do you get to the data that is being generated at the edge? Typically, and traditionally, you have to move either data or you have to move the compute. Moving compute is very challenging, especially with complex applications that require a significant amount of resources. So we typically move data. And what we do is we migrate it. We migrate it to the data center, and there we process it. So the challenge there is the delay, right? It takes time to move data. And the same time, every time you move data, obviously you expose yourself to potential, security complications with the data. Um, we oftentimes also make copies of data, whether it's cached or just copies to everywhere where the application may reside or we need to process it. So now we have multiple copies. We have to create now data protection policies, security policies all around this data. And then there's times that, there's data sovereignty and issues around data cannot be moved, period. So that, creates this very fractured environment, compute environment. So that's one challenge, because the result of that is that your insights, your business value really relies on how quickly you can move the data. The second challenge is that we're all striving to figure out how to take advantage of the elasticity of compute and the elasticity of resources in the cloud. Everybody has sort of cloud first type of initiative. In those situations, whether you want to burst or you just want to take advantage of something in the cloud, you have to move the data into the cloud. And again, it's the same delay, because when you're moving over long distances, you become victim of the inefficiencies. TCP was never designed for long distance data transfers and data processing. So that becomes a real challenge. So what Vicinity has developed, and we have 32 patents, one pending. This might not be a very short pitch to what we do, but the gist of it is we enable applications to process data at the point of creation, and at the time of creation and at the point of creation. In other words, you don't have to move data in order to consume it by applications. We have enabled the networking technology to be able to eliminate the intermittence of latency and the effects of latency. So once you experience that first byte, the rest of it feels like you're on a local area network.
Now,
So now
this is
you eliminate all that time lag required to move data and do all that other stuff.
This is always a fun discussion once we bring the word edge in. And I remember early on, like when people said edge, it was always this assumption that edge is like a Raspberry Pi glued to a cell tower in a forest somewhere like that. Like, no, edge is anywhere where it's closer to the end point of consumption. And that could be a user, a group of users, a cloud area, a regional area, a data center, or a cell tower sitting in a forest somewhere. Who knows? So do you find when we talk about edge that the next thing you have to do is explain to people what an edge scenario is? Or how are you finding the consumption of that description now in the market?
Yeah, it's a challenge. Everybody has a different idea of what an edge is. I think we kind of target a few specific use cases that make it simple. So we have a proliferation of IoT devices, and these are not just your Nest in your home that is controlling your heat. These are cameras, these are sensors, for anything and everything. I mean, there's thousands and thousands of them. I recently read a quote by a CEO in the shipping industry. I think he said that, you used to be a couple of hundred, maybe, sensors on a ship, transporting goods from one place to another. And now there's thousands and thousands of them, and they're all generating information and data. And this data can be used for a number of reasons, different ways. For example, it could be physical security assurance. It could be navigational assistance. It could be operational efficiency, right? There's lots of different things depending on what the purpose of that is. But you can't do that, right? The ship is in the middle of the ocean. You got satellite links. Potentially they're really slow. So then you get all this data coming in once you get to port, but that's already delayed, right? So the value is no longer there. So what is an edge? Realistically, it's when you're far away from your compute, from where your applications reside, where you're generating the data, and where you need to respond to something, right? You're delivering some kind of value, whether it's traffic control, whether it's, again, physical security, or, I mean, there's medical is booming, in the healthcare industry, with edge devices, especially sensors,
Right.
or whole body sensors, informing doctors exactly what's going on with you, and all the time. So yeah, edge really has to come up with a few specific use cases. So we focus on AI ML on one hand. There's a huge one in media entertainment broadcasting use case. We do definitely make satellite links work for you. So anybody who's got a satellite or has to access data or process data, ingest data over satellite, we make that possible. So those are some just, short-term acceleration of adoption of cloud. I mean, you could be data in the data center, but you want to, burst into the cloud because you want to deploy the elasticity of the compute, but you can't because the data is sitting on the prem, right? So now you can do that. You can deploy the compute in the cloud, process data without having to move it.
I also got to give a shout out to two fantastic things about your company that I love. Your product names, first of all, are awesome. I'm like a longtime cyclist and I used to be in like BMX and stuff. And so I laughed when I saw the name of the products, like Radical X, Ultimate X. I'm like, this is so cool. It like sounds like a cool product. And a thing we'll get into, let's talk a bit more about platform and some of that stuff. But you very openly describe our misfit culture. So I'm going to dig into that one, but
Okay.
let's spend a bit more time on the tech because I think that's important. So you talk about satellite and we talk about a couple specific use cases and it's funny, like you said, everybody has a different description of edge. And you've been very good, I think, in describing edge as a generality versus most people are like an edge is when my thing can solve a problem that you've got. So I do like that you have given a much more open description of the use case. It happens to, fit into what Vicinity can do, but I appreciate that it wasn't immediately just I've got a hammer and I'm going to tell you what a nail is.
Thank you.
uh, but so the team
Mhm.
and the technology, what drew you as a group to come together to solve this problem?
So it's interesting. So Vicinity has an interesting history. Going back a couple of decades, there was so if you think about what we do, we enable real-time access to data. And if you think of it from a government perspective, who wants to know what's going on across all the different theaters that they're involved in, and oftentimes, it's time, life and death, or
Yeah.
however. So they actually funded a research project to develop technology that would enable them really to have that real-time access to data. And so there was a company that was founded from that project called Bay Microsystems. And they really provided very customized solution to predominantly government entities to enable that real-time access to data. And so process in place without moving, et cetera. So in 2018, Vicinity was incorporated as a way to commercialize all that research and all that technology and to bring this to the broader marketplace.
Now that's also what I liked about the backstory of the general company is that this is stuff that is heavily researched. You talked about patents and I don't necessarily see that as like a significant differentiator, but it shows the background to sort of the tried and tested approach of like let's do the deep research as an intellectual community, make sure that this problem is worthy of solving. Have and
Mhm.
it's like the whole peer review and the way that we approach research is very different. And then to then take this and bring these novel, technologies as patented capabilities into the market is now consumer available
Yep.
versus there's some kid that goes to a Starbucks and is tired of watching people's dogs poop in front of them, so he invents the poop upper and like incorporates it on the spot, and like there's the purely this like a functional idea solved versus like the history that comes in, and now this team reactively will adapt to the real life use case. And you worked at scale to start with, which is also interesting. Like you literally
I
you
didn't work at scale. Oh, at scale, yes.
Yeah, yeah, like, so it's like they solved a large problem, and then we've kinda you can sort of scale it down to consumerize, I guess, what the use cases are, which is neat.
Yep. And create more of a solution set from the technology rather than just, present a technology to the marketplace.
Yeah, and it's tough as it right now, like, the pundits will say, we talk about the phrase, like, a technology, problem looking for a solution looking for a problem. But that's how these things need to get solved. That's a cute saying to sound like people are like, really nifty pundit analysts. So like, haha, this is neat technology, but there's no real answer for it. Like this is how stuff at this kind of scale gets solved. You don't just whip it together at the Starbucks and then kick the tires on it and then fire up a single page funnel in order to get it sold. This is a very distinct and long term problem that had to be solved.
Well, I think that, the way that we can maybe articulate or think about it is Um, I worked in the data protection space for a long, long time. And we always talked about RPOs and RTOs, recovery point objective and recovery time objective. Also in relation to business continuity disaster recovery. You had to know how quickly you wanted to recover and how much data you were willing to lose or how long you were willing to be down. Of course, nobody wants to lose anything and everybody wanted to be up and running immediately. But, based on what it would cost for them to do that. The pertinent sort of phrase here is recovery time and recovery point objectives, right? It's the recovery word. When you think about access to data, right? Even in a data protection scenario, you don't want to recover. You don't want to have a copy or your backup data. Then you have to copy it so that the production applications can actually consume it. You just want access to that data, right? So think more about, so the way I like to think about it more is that the problem that we're addressing is, what is your access time objective for your organization? So if your access time objective, in other words, the relevance of the outcomes and the relevance of data will change over time, right? So if you're going to tell me that there's going to be a traffic jam down the street before I get to the last exit off that highway, then that's good. That's relevant. But if you're going to tell me while I'm already stuck in traffic and I can't get off, well, man, that's not it's not going to help me.
Exactly, not helpful at all. I'm
No,
acutely aware of my situation.
exactly. So it's the same thing. So it's a concept for the enterprise and for the applications that are dependent on the outcome of processing data, analyzing data, inferencing data, whatever it is that we're doing with unstructured data. This is not a database application, front-end database application. You are now delivering the access time objective that is best served, right? So I guess another techie maybe example is a lot of applications used to be written with the understanding that there's going to be a delay, right, in response
Right.
when you run it. Okay, so if you accelerated this, there's a company I did some work for called PlexiStore. Excuse me. And what they enabled is it was a file system that terminated transactions in memory.
This is a lot of folks would probably actually know the name too, because this is one that has come up as like an interesting problem that was needing to be solved. So yeah, so keep on going on with that one.
Yeah, so the transaction would get terminated in memory, but the file system, I mean, you have memory file systems today, but what they don't have is the ability to then tier it off into persistent storage. So PlexiStore solved that problem, right? So they could terminate in memory and then they could tier it as a tier to persistent media. And if you use something like NVDIMMs or some kind of a persistent memory technology, you could have, well, DRAM speeds. So if you're doing a database application, you didn't have to wait to get a response, which is what the applications were designed to wait for. And what was interesting is to see how the different databases, reacted to that technology. So one database, we could get down to, 2 microseconds.
Wow.
Right? So if you think about CPU consumption and utilization of your processing power, that's like, that's pretty much full.
Yeah.
But other applications inherently had latency built in because they knew that they would have to wait for something to happen, right? And so you would still, it would still, something like 120 microseconds versus, 2 microseconds. But it's still an enormous improvement over something like, a millisecond or 2 milliseconds. So it's the same concept here, is that with access time objective is, how fast we're used to, and we've calculated in all these inefficiencies because our assumption is that we have to move something and then we have to wait, and that delay is sort of built in. But what if it didn't have to be built in? Wouldn't we have, no delay required?
This is it's the assumption that we've had effectively since the 70s is that we kind of built on the fact that there was these latency amongst and between tiers. And then on top, so distributed systems didn't exist because it was not physically possible to distribute systems.
Right.
There was the speed of network was not possible. The speed of media was not possible. They didn't have message queuing. Like that was not a thing, when we had the dawn of computing. And then we got further and then we developed like large centralized systems. And then we had distributed systems because now the software was smart enough to know to wait, as he described, right? And so we started to build this. Well, now the funny thing is we think that everything has got to be built that way. And if you get into distributed microservices architectures, you do have to be prepared to wait, but the wait is no longer required. And it's by a friend of mine, he's at a storage company, and he says, we actually have to introduce delay in our writes because the software can't keep up with us. So we have to slow it down in order to let the world catch up.
Exactly.
So the tech is now there to do this, but that's localized. And now you're talking about making this not just a pure low latency, immediate, like physical connectivity, but you're going one step further. And we're talking about this ATO. And I like this. I like this new term. Can we define an ATO, like an access time objective, like an SLO, a service level objective,
Yeah.
and then effectively then now tighten the band on that?
Yep.
So now the question comes, Noemi, what does this do that is different, in when it didn't exist in the market? We talk about the speed of connectivity, when you talk about
Mhm.
synchronous database writes, we talk about synchronous writes that are doing through tiers. Just didn't exist before. So what's the sweet secret sauce goodness that's it's patented? So of course I could go digging through the patents and we could unpack it a bit, but let's
Uh,
make it more English.
so the gist of it is when the original researchers and developers looked at, TCP is not a efficient protocol, as we all know, when it gets into high latency, because it was
Right.
really designed for accuracy and for data integrity. Um, and we could argue at a cost for timeliness, right? For throughput. And then we have UDP, which is well, it's a broadcast protocol. So I mean, you can add some things, and it does improve. But when you start going over higher latency, it also has significant delay. So you get 20-30% improvement over what you get with TCP. But in both cases, you can't do anything. It's not fast enough to actually process in place. So you can move data with UDP faster than you could with TCP, but you still have to move the data. So what they thought about is more of the RDMA protocol, which was used in high performance computing, right? It's
Right.
memory to memory. So it's very, very low latency, but it cannot be stretched over networks. So it has a limitation. So they took RDMA, and all the patents are around enabling to stretch that protocol across the WAN. So it's a layer 2 secure tunnel. It's a point-to-point solution, which enables us to do all sorts of interesting things around security of the data. But it's leveraging RDMA, and the way I say it, it's encapsulated in Vicinity patents.
Right.
And then it's
Yeah,
given,
there's obviously there's always the weird thing too when you tell people like you can read the papers, you can see the structure by how it's created, and they're like, can't somebody just copy it? Like, sure, go for it. Like there's a lot more than just like, in fact, exposed, patents are fantastic for companies because they're like, we're literally airing out precisely the method that
right,
we've attached to this. How we do it is known, but no one has been able to do it even when they presumed that it could be done. And that's the secret sauce, right? It's
yeah,
in the code.
exactly.
There is proprietary IP that's either under or above it in this depending on the case, right?
Yep, yep, yep. So it's they created a bookend approach, which means you have to have Vicinity instances on both ends that are communicating with each other. So the application and the data, those ends have to communicate. But it's not limited one-to-one. You can do one-to-many, you can do many-to-many, you can do many-to-one. So it's just a matter of, then you get into implementation, configuration, etc. But you do need to have Vicinity on both ends. And there's, the opportunities for this technology is just, immense, which is what attracted me to the company in the first place.
Absolutely. Well, if the only places that this method has been used is for passive data. I mean, and this goes back to sort of the data domains and the early sort of back appliances, stuff that was being done in WAN acceleration, primarily for like just simple user level transactions to back end systems because of very low, low bandwidth, high latency network. So it's mostly like HTTP, some, SMB, but it was like generally always passive workload connectivity. What you're talking about is literally being able to do active and system to system connectivity, which is, the exponential leap from all the use cases that have been tried and tackled. And still, to this day, as people are still trying to solve that problem, even with different ways of attacking the technology.
Yeah, it's an interesting thing that you bring up in terms of passive versus active, because in all the ways we've really, all the innovation and all the technology has really been focused on how do I move data faster, and how do I give access to data by moving it faster or caching it faster, right? Or caching it better, more intelligently with prefetching and things like that. But even with WAN acceleration, it depended a lot on both deduplication, compression, and caching. And as you can imagine, if data was already encrypted or compressed or dedupe, you're kind of, not
Results
really.
may vary, as they say. Yeah.
That's one way to put it, right? And the same thing with caching, right? If you had a very predictable workflow and workload, you could arguably say, okay, data created, I know that I'm going to be processing it in the next, however long, I'm going to move it and, cache it close. Now, we're going to assume that you can move it quickly. So there is still a lag, right? Because you have to move it. But let's just say, you prefetch it, you make it available, and it goes. Well, what happens if your workflow is not as predictable, right? Then caching becomes a lot more complicated and much more expensive, because you either have to have a much bigger cache to cache more stuff, or your accuracy is going to go down. So with Vicinity, because of what it is as a platform, we don't really care what data you send. In other words, what data we need to access. It can be already encrypted, it can be deduped, it could be compressed. It's still going to have the same result, regardless of any of those things.
And this is, if for anybody that's watched Silicon Valley, we know like encrypting is, encrypted data and like data that can't be compressed is seriously problematic. You talked about network, broadcast networks and stuff, and satellite connectivity. This is a huge problem. This is data that just, when you go to all those deduplication vendors and they say like, oh, we can get 25 to 1, like, really? On what? Notepad documents? Word documents? How can I'm sending 17 terabyte video files in raw format? And they're like, I can get you about 1.001 to 1 on that stuff. Like, okay, so stop telling me about your 25 to 1, please. Because I always used to get blamed and be like, "Oh, you've got bad data. That's the problem." Like, "Oh, sure, blame the data."
Well, that's why that technology really took off in the data protection space, right? Where you had repetitive, because it was file-based backup, so the same data was, constantly over and over. So there, you could have really high dedupe rates. The same thing with virtualization, right? You can have virtual machines running the same OS, you can get a huge deduplication ratio. But yeah, when you get into kind of unique instances of data, video file, audio files, images, which is actually, I think, where majority of the data is going. Becomes like
Definitely.
it becomes a lot more, difficult to apply those techniques.
And even, as we introduce faster networks, it doesn't actually solve the problem because as fast as 5G becomes a reality, the workloads are already queued up waiting. Like once we announce that 5G is a potential, all the vendors out there are like, all right, 5G is coming. Let's open the doors on this. And they change the pattern of the way their software works. So the moment 5G is a reality, no one will notice because we've already caught up to it before it even arrived.
Yeah, and I mean, the speed of the network is really important. I think that when talking about long distance, though, um, and I learned this a long time ago, even in storage, because that's my background is storage, is that latency. Nobody talks about latency, or very few people talk about latency.
Right.
But that is the biggest culprit for inefficiency. I mean, whether you're talking about processing in memory or processing over distance or storage, access to all of it, it's latency. And even with faster networks, distance is distance, and you can only do so much with latency. I mean, we haven't figured out how to. What is it? The wormhole technology. What was it like?
Right. Yeah.
Pop on the other side of the universe. I don't think we've figured that part of physics yet. So
No, sadly, while we think that Einstein might not be 100% right, he was mostly right. And we haven't actually, and where he's not right is not in around basic latency. It's around really impressive stuff at a significant scale. But yes, like I said, this,
yummy.
no matter how you slice it, I did disaster recovery and BCP. It's funny, you talked about this. You thought edge is hard to explain to some people. Like I, I worked around constantly educating, just even RPO and RTO, trying to explain something.
Yeah.
Okay, so your RPO is 5 minutes for the system. Like, okay, good, gotcha. All right, it's gonna take us 2 hours to recover that. They're like, wait a second. I thought you just I thought you said it was 5 minutes. You're like, no, it's recovery point objective. Like, but what's the 2 hours? I'm like, it takes us 2 hours because of other things that are dependent systems or whatever. They're like, so in 2 hours, it will be 5 minutes behind. And I'm like, right, from the point where it failed. They said, so it's technically 2 hours and 1 hour and 55 minutes behind. But, and it was like, and like you said, everybody wants zero. They want RPO of zero, RTO of zero, and
Mhm.
they have a budget of zero.
That's very accurate. That is very accurate. And I have had to have those conversations quite often. How much data do you want to lose is your RPO, and how fast do you need to have your application up and running is your RTO. And in disaster recovery scenario, um, that was always a much more difficult thing to discuss than in the backup scenario, right? The data
Right.
protection RPO and RTO is mostly around how often you want to do your backup, so how much data loss you have, with the assumption that you can bring that, you can restore the individual piece of data. It's really about business continuity and disaster recovery, where recovery time objective becomes, critical. Um, I think as we move more and more into this, data rich, data driven AI, ML, analytics, and just distributed environment, I think we need to start talking more about, access to data, not just recovery of data.
For sure. It's the new batch versus real time, right? It is very much this next, shift in the way that we talk about workload consumption, because these are where systems consume data, not people. And
Correct.
they are the primary consumers. And then those systems have endpoint consumers. But
Yes.
that mid tier of consumption by systems from other systems is where that's where businesses are differentiating right now. That's why Amazon is different, because they solved a problem that no one cared to solve because they were worried about what the website looked like and what the dropping the truck, at the end of the driveway looked like. Amazon's like, we're going to solve the logistics problem. And
Right.
that vastly differentiated them from the rest of the world because of how they did that.
Well, they're still having, interestingly enough, one part that they haven't solved is how to get data into their cloud fast enough so they can start
This is true.
generating revenue. So there's a huge backlog, and I mean, Amazon is just AWS is one, but there's the challenge of how do you get data. I mean, if you think about, we're getting into 2 gigabit, there's 40 gigabit, 100 gigabit networks, but let's just look, even a 1 gigabit, just typical 1 gigabit link, you'd think you'd be able to move 120 megabytes per second.
What one
That's
would
line,
believe.
one would believe that's line speed. But once you get into latencies of 40 plus, or even less than 40, um, you're lucky if you can get 10 to 12.
And top that off just with, of course, just general protocol communication. Like, it's not as what we're sending a raw hunk of data. Even when you explain that to folks, they're like, so I've got a 100 megabyte file. It might break it down. It's going to take this long. Like, well, no, remember there's packet headers, and then there's there's CRCs and error checking, and then there's latency. And,
Yeah,
so in the end, once you lay that out, you realize like, oh, wow, okay, now I get it. And then you say,
right.
okay, now the consuming system on the other side of this is using real-time machine learning to generate inference in order to generate data that it's sending back. How do you think that's going to go? Right? This is where I'm like, I like these Vicinity folks. I think they're going to be doing some pretty neat stuff.
Yep. That's true. I think people don't really they don't think about it. They think, oh, I have 10 gigs and it's going to move really, really fast. But, when you get into WAN traffic with TCP, you're lucky if you can get 10% throughput. And you can't, the further you go, the less efficient it is because, again, TCP is really designed for accuracy and integrity, and, it's a lossless protocol. So, yeah, it makes it really difficult. I mean, you can't process anything over TCP over distance. You have to move the data.
Yeah. But and this is it. Like, most of the use cases where it needs to be solved the most are in over the air. Like, this is satellite. This is not line rate firing across the undersea cables. This is South American mines that
Yeah.
have nothing but a couple of towers on big hills in
Hmm.
order to move data back and forth. Yet they need to move the processing there because they're making real-time decisions in how they run their business. And the data center is in, even if they're lucky, it's in the Sao Paulo region of AWS as an example, whatever. But still, it's far away from where that local environment is. And so this is why, that line speed is no longer something you can live with.
No, I mean, if it takes you 22 hours to move a terabyte, and terabytes is not a lot of data these days.
That's right.
Every time you move a terabyte, 22 hours, that's 22 hours of potential productivity, potential moving forward on a project, getting the accuracy right, whether you're mining or drilling or, I mean, this is not just in those industries; it's across many, many industries, right? I had this conversation recently with someone in the life sciences space, and there's a consortia of entities. They're procuring this super, I mean, these are like multi-million dollar machines that are going to be used for experimentation in life sciences research. And so they're collaborating. So they're going to get, let's say, two of them in two different locations. There's three or four of them. And so they're all at a far distance. And one of the use cases that was brought up, one of the challenges is if you're running an experiment in these experiments often run for hours and sometimes even days, that you want to make sure that the data you're getting out of them is good data, right? Not junk. And you want to catch if they are miscalibrated in some way. You want to catch that as soon as possible. So for them, having that remote access to the data as it comes off these machines to be able to say, yeah, this is good, this is good data versus bad data, can save them days, hours, you know, potentially weeks, because they're lined up pretty tight in terms of experiments being run. So if you miss your timeline, you have to recalibrate to do it. You've just missed your window. Now you got to wait till the next time, and the cost of research, the cost of everything goes up.
It's terrible in that, like, we have, again, the sort of this, as consumers, you just kind of assume that a lot of stuff just should work, but like, especially at that level, I remember, through my own, my day-to-day work, helping folks what they're doing in stuff with like life sciences and medical research. And they're like, no, like, you understand, this is like hands-off technology, because if anything goes wrong, if we lose 1 minute of data, it is 4 months of replay. It's not, you can't just pick up where it left off. Like, they have to, and this is obviously, we're getting better, we're tightening some of the time, but no matter how much you tighten it up, it's more than zero.
Yeah.
And in a competitive space where they're competing against each other or competing against a pandemic,
Yeah.
every second counts.
And that's true. I mean, that's true across so many different segments of the market. Whether you have your news organization or a broadcast company or media entertainment, you're creating content and it's created here. But in order to accelerate processing, the dailies, for example, you want to do that quickly. You might have to have some resources on site, but then you have to somehow transfer the data. You still have to move it, and then you have to post-production facility. They want to use the cloud, but anyways, so there's so many different instances across all industries. You get into manufacturing, you get into energy exploration, mining. Yeah, medical is a huge, healthcare is a huge industry for that. So yeah, it's
Well,
cool stuff.
it is wild. And so I'll say, let's talk about the minds behind it. When you have a big problem that has a small window of chance to be solved, and you just say, like, they laser focus on that one, and you describe your misfit culture, which I love. Let's dig into what about Vicinity makes this team want to do this, and also how are they doing it and being successful at it?
So the team that is in place now is was recently brought in, probably starting last year, and the goal is really to put it on the map. Uh, you know, the company was incorporated and launched really in 2018. We're in 2021, and when you ask, oh, have you heard of Vicinity? Because we do something really unique. Most folks don't know who we are. So we have a little bit of a challenge ahead of us in terms of building awareness, educating the market. I still go back and reference when I was, back in 2004 when Data Domain, I think, first came out, 2003, 2004, with their first version of their product. And I remember I was in sales, solution architect, and I went to one of the customers, and we did a big consulting project, redesigning their data protection environment. And I said, well, there's this really cool technology, and here's what it does, and this is why you should look at it. And we spent more than an hour trying to explain to them what is deduplication, why you don't lose data using it, what are hashes, how it reconstitutes, how it does this, how it does that. It was an uphill battle to some extent, because it was something that people didn't really know. What is deduplication? And I feel that we're in the same kind of position now, where we're trying to say, just like we had to explain that deduplication is for real, right?
Right. Yeah.
And it works as advertised, when within the confines, of course. That our technology too is very new, it's different, it's unique, and then it does work, and it does solve a real problem for people. Because the first reaction typically is like, oh, this must be like, no way. I
Yeah.
don't believe it. I don't believe it. So, so there's a little bit of an uphill challenge, and I think that the team that is in place now is very much focused on educating the market and being laser focused on getting the message out and working with customers on the appropriate use cases.
The challenge we've got is that when you're selling anything and humans are the people you're selling it to, is that humans, especially technologists, have a disturbingly high pain tolerance. I describe this people, I'm like, you'd be surprised at what we're willing to do. Ask any nerd how they set up their home stereo audio equipment, and they'll tell you about like cable lengths, like all this crazy stuff they went through. You're like, I could get the exact same thing out of this box, whatever. And they're like, I like cutting my cables by hand. It takes me 3 weeks to do it, but there's something about this tactile feel experience. And you're like, these are the people I have to sell enterprise software to. I'm going to go hungry.
Yeah, no, there's a lot of, I mean, there's some of that. I guess lucky for us, it's not something that anybody else can do.
Right.
Um, but accepting it and you say, well, just leave the data 3,000 miles away and just process it like where it sits,
Yeah.
What?
Yeah.
So it's a little bit of an uphill battle, but I think we're in a good position to make a push for it.
No, and I think the industry is ready, as well, because the use cases are active and are real. The tough part when you have stuff like this that is gonna be a fundamental shift in the way a technology and a solution can be generated and what business value can be gotten from using that technology. When it's a big shift like that, it's it's tough, like, just general awareness is one thing, but teaching them that to be self-aware that they have this problem and that they are then willing to bet on a new company to solve that with them. It's a lot of interesting things. And look, on the other side of it, we could name dozens of companies just out the back of our hand, right? We that they at one point said, so why do you call the company Oracle? I don't understand that. Like, whatever it's going to be, there's some Larry Ellison was in a room going, I'm telling you, there's a bloody better way to do this. You're at this neat point right now, Noemi, where, a combination of team, industry now, growing awareness and readiness. I see definite, high potential for you.
I do too. Otherwise, I wouldn't be here.
That's it. So I got to dig into your story a little bit. So first of all, you talk about your VP of marketing today. You're
Mhm.
incredibly technical. You talked about being a solutions architect in the past. You've got a strong technical background, which seems like a natural foray from studying history. So let's connect the dots over your lifetime and what brought you to where you are today, and how did this journey begin?
It was an accident. I think a complete accident. Um, I was I don't, I've always been a big fan of liberal arts education in general. Obviously, I have a history and a literature degree. And when I graduated college, at first I thought, no, I'll go to grad school, this, that. I tried a lot of different things. Ended up in telecommunications, sort of, as a side, and then went to grad school and got an MBA. And it helped me kind of explore new, different opportunities and sections. So I got lucky. I was brought into a company called Genuity, um, and ended up in a product strategy group. And back in 2000, was asked to write a market requirements document for storage services. This is the time of storage networks and storability and
Right.
Giant Loop and all those companies who are trying to do sort of what cloud does, but not exactly. Um, so we had our data centers and we had hosters. We were hosting applications and infrastructure. And that's how I got introduced to storage. It was, just somebody had it, and it's like, well, we need somebody to write this MRD, so go figure it out. Um, and I did, I guess. And I stayed in storage after that, just going from product management to startup in you know data protection space with virtual tape libraries, then into sales and solution architecting. Um, and it was one of my colleagues who said to me, you're really good at explaining things. Maybe you should consider being an analyst. Like, oh, okay, sure, why not? So I went and became an analyst for a number of years, and then so it's been an interesting, not exactly the traditional path.
That's the best path, because I think this is when you look at folks who've taken the non-traditional routes. I think that's where you find, first of all, you're an incredible person to share time with. I could do this for hours, and we could go into probably an incredible array of background topics. And that's what I love, is when you can connect with people, and because they understand, like, their storytelling and connecting. Technology is a particularly interesting space because you're I mean, I don't necessarily know, like, other industries directly, but I can say this, like, we have to have this thing of, like, positive business outcomes. And then in the middle, you've got to sell it to the people that become your champions and your users, and all of this stuff that goes on in between, and connecting value to technology. And we always get told, as in storage, right? Don't get hung up on the speeds and feeds, then followed by spending 2 hours explaining the speeds and feeds to people, because that's actually a differentiating capability with how we tackle some of this stuff.
Yeah, no, I think that throughout the industry, it's really challenging for us to step away and not focus on the speeds and feeds, because that's where that's the natural sort of um, point of migration. That's where everybody sort of goes right away. I have to say, I I think I'd like to think that my background in liberal arts is what gives me sort of willingness and desire to take a little bit of a different route. I like to tell a story, make it sort of personal, um, put a little humor in it if I can get away with it. Because when you start reading, whether it's a data sheet or solution brief, after a while, they all sound the same. They all start the same. They all sound similar. We all do the same thing. We give you this value, blah blah blah. But it rarely connects with you at that personal level. Where it gives you a little giggle, or maybe you just remember it just a little bit better because it said something that you could relate to.
It is incredibly powerful to be able to put that, and it's a surprisingly rare capability to do that. And you may not even necessarily realize it because you've developed it. Some of it is born, and most of it is nurtured, generally, because we learn from watching it happen before us. And it's, and I often tell people, like, one of the greatest sort of storytellers as far as like brand recognition is a fellow named Donald Miller, and he has a thing called Story Brand, and it's actually something I use. It's fantastic, and it's this whole idea of, like, in one line, can you explain what you do, and not like, well, so what we do is we, like, you like, don't get into the what you do, but you're like, everybody has this problem where you have two-story houses and the toilets, one's on top of the other. Well, we invented this thing called the toilet reroute, so that the person on the bottom never has to understand what the person on top's doing. Like, and that's the story of the toilet router. Like, it sounds so funny, and like, we sort of throw it away sometimes as a joke, but like, that's how we have to do it. And like you said, you read data sheets and white papers and press releases. God help us with the press releases today. World leading, whatever, first to
Everybody is.
announce. Yeah, it's exactly the same first paragraph, middle paragraph, executive quote, followed by customer quote, followed by second executive quote. For more information, go to the media page. It's like, it's just the same thing over and over again. I think it's only meant for PR people to sort of satisfy that, like, that machines existed for a long time. It used to be literally like dee, 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 like the little teletype wire would be hammering out something in a remote location, and
Uh-huh.
quick, the Associated Press would be like ripping it off. The like, quick, look at that, something just happened in Boston. Uh,
That's
but
exactly it.
but to be able to not just differentiate in technology, but differentiating in helping someone care about what you do.
And have
That's a
fun with
pretty
it.
cool thing.
And have fun with it.
Yeah.
I mean, uh, at some point, it all comes back to, why should you care how fast you access your data? Well, like I said, you're on a highway and you want to know that there's a traffic jam and that you can actually exit now or when you're stuck in traffic already. Just as a simple example, there's lots of those kind of stories we can all sort of tell. There was I remember I was writing something and I thought to myself, well, how do you really convey the idea of data relevance or any kind of relevance and relevance of value at a point in time? You can get very technical about it, but and the one way I came up with, see how it works, is the value of your bandwidth, reliability of your network is more valuable while you're watching a movie or playing video games than when you're sleeping. That's the relevance, right? That's the relevance point,
Yeah.
or time relevance.
And it's like, to find those analogies. I worked with a fellow. He was our development team leader, and it was so funny. We used to always joke. We had like we joked about it because he was so overt with it. Every time he'd say something, he like, so Alex, how are we going to get this into work? He goes, imagine you're in a restaurant, and you're like, oh jeez, here he goes. Like, oh no. So we would
Mhm.
always joke, and everyone's like, hey, the internet's down to, like, imagine for a moment that you're a subway driver. And he like, no, like, but it was in the end, he was so fantastic at connecting you to what the real problem is through the way you do it. Just every once in a while, he got a little hung up on the story, but it was so funny that now that I read, and just even like just the simplest example that you gave, it's so elegant in its simplicity, but 99 point X percent of the population cannot create that simplicity.
Never thought
And
about it that way, but
what was the old Mark Twain thing? Is if I had more time, I'd have written a shorter note.
that's a great quote. I'm going to have to remember that one.
Brevity is brevity with detail is an incredible challenge, and making it relatable is one of the best ways to do that, especially as like not just in the written text that goes on a website, but yeah, when you get in front of somebody and explain what you do, and how it helps them, and who else it helps as well. It's good. So I'm excited. Now, this is the other thing too. I'd love to get your thoughts on this, Noemi. How how do we as humans and people that are looking to get into technology or technical marketing, or these different parts of the organization, how do we how do we pick this up? Right? Like, you talked about, you've always enjoyed that you choose a liberal arts as your education. So if we've got folks that are, sort of tried and true technologists, and that they're learning, I learned Java on the weekend, that kind of person, like, what's the way that we can help them to become storytellers?
You know, that's a really challenging task, or a challenge, a big challenge, because everything that you do requires practice. So nobody, I mean, yes, there are people who are fantastic storytellers, um, but for majority, like 99% of the population, I think that just like in writing, nobody wakes up one morning and is a fantastic writer. Um, some people are better than others, but to get better, you have to practice. And I think the storytelling is the same thing. You need to practice. The reality is that, if you're the technologist who is reading books on Java, you're probably not practicing storytelling,
Right.
and it's probably not an interest to you either. Um, so if we, I guess, require everybody to tell a story or to try to try to convey that, but I guess at the same time, maybe that's why we have people who try to present the technology in a story sort of format so that people can consume it. And then there's those who sit and write code.
Right.
Um, you know, maybe they don't have to tell a story. Maybe they just need to write really good code.
Yeah, and I guess it's the magic of teams and communities is that we don't all need to do everything. Yeah, the singer in my band one day, he was like trying to teach our bass player how to sing. He's like, "Look, it's easy." And I'm like, "Bill, you have no idea what you just said and how wrong it is. And it's easy. It's a skill that you've worked on as a trade for a decade and more, right? You probably did choir as a kid and you're 22 years old and you're a fantastic vocalist, like disturbingly good.
Hmm.
So of course it seems easy, and he's just like there's physical boundaries from somebody else being able to do what you do that require years of training, and even with years of training, maybe you can't. Maybe Pete should just play bass. And that's fantastic. Like that, and that's what part of it is like, I guess for the folks that want to get into product management and product marketing, there
Hmm.
are good ways we can connect them and introduce them to storytelling and practice. And then it's important to understand that there are going to be folks that are raw technologists, code creators. Their creative mind is very different.
Hmm.
So I'm impressed by all of it. Like I sit there and I think that I'm a smart person and I start typing in code and I realize like the wall comes fast and quickly on how far I can get. But that's why you find a co-creator, somebody
Yep.
who can do code, and then you find the shim between the two of you where you can say, I'm going to describe a user story now, and they take that and they turn it into code, and it's and product and usability. It's actually quite amazing.
Yeah, and I think, I mean, if we were all sort of good at everything, I don't think it would be as interesting. Um, so I don't think I ever want to write code.
And I'm going to say on your behalf, I bet you've written more code than most people, and you could. You're just given that your understanding of it, you'd be surprised at how far you'll get. But I also have an incredible respect for the fact that you've set that boundary that you don't want to, nor do you believe that. Like, so it's a very beautiful respect that you give to a code creator, that you've set your line that I don't think I'm gonna want to do this.
No, no. I think it's good to have, people who are good at what they do and what they enjoy doing, um, and to collaborate.
Yeah.
I'm big into collaborating and sharing ideas. So I think that's a much more productive, longer term because of, yeah.
I think we're, at a beautiful point, at least now, where the world is sort of, I'll say, reopening, and we're going to reconnect in ways that we haven't been able to for quite a while. And I think people will have a greater appreciation for that collaboration, and through the way that we've changed the pattern of work and society for now, 18 plus months. I really hope that we take some fantastic lessons from the way we had to readjust, the way we collaborate, and now we're going to merge them together. And I'm excited. And Noemi, I mean, looking at what you can do, um, I'd say I wish you luck, but I know it's not luck, because it's luck is that the amount of work you put into it increases your exposure to luck. And you have been increasing your exposure to luck for a long time, and doing it well. So
Thank
the
you.
the Vicinity team is in good hands, and I look forward to catching up as we get further into the year, and hopefully get
Absolutely.
some more of those press releases. There you go, August 2021. Today, Boston announce Vicinity does amazing things.
Well,
That's
hopefully we will be able to announce some amazing things. But in the meantime, we will focus on execution.
definitely. Well, and it's funny. One of the most recent published podcasts that published was an amazing woman named Michelle Seiler Tucker, and she is in the business of buying and selling businesses and helping people to create,
Hmm.
strength in business in order to exit successfully, especially for like buying up distressed businesses and helping them to find sort of maximum value and protect everybody. And the one thing that she talked about was that companies that are less than 10 years old are having a significantly higher success rate than incumbent 10 plus year companies. So this
Really?
whole sort of this trope of 90% of startups fail, or 95, whatever the number is that we throw on, she's actually completely reversed. In fact, 70% of incumbent businesses are at a failure rate right now, and 30% of startups under 10 years are failing,
What did
according
you
to
say was the
small business.
reason? So did she explain why?
It's partly because the rethink of work patterns. The economics are different in that we can access cloud computing, software as a service. So getting a business up and running now, depending on, like, there's obviously some, what are the size of those businesses, how much of them are just Amazon affiliate people, whatever. Like, but in general, according to the Small Business Administration in the US, statistically, the numbers are an inversion to what we've been told for a long time. And the funny thing is that, they're not sexy sounding numbers that way. So no one, everybody likes the 95% failure as if it's like, aha, we're going to do amazing things. You're like, no, actually, in David versus Goliath, as Gladwell said, Goliath never stood a chance.
Mm-hmm.
And in fact, it was David that has the most to lose. And it was kind of funny that now, as we look at, like I said, at your age of the company, where you are, I do see some fantastic press releases coming soon.
Well, I will absolutely be back in touch with you as soon as we're ready to announce.
And so for folks, if they want to connect, of course, we can go. I'll have links to the Vicinity site. Easy to find. It's Vicinity. That's always the neat thing when it's like slightly different spelling than one
Hmm?
would expect. And Noemi, if anybody wants to get a hold of you, what's the best way if they want to get in touch?
You can reach out to me on Twitter. It's GREYZDN on Twitter. That's my handle, or on LinkedIn, or post on the LinkedIn Vicinity site. The easiest way to do that. And I hope to hear from folks.
For sure. No, and definitely. So there you go, folks. Reach out. There you go. Tell them that they're listening. It's always the hard part too. Is I'm like, people will. There's nothing worse. They're going to listen to 98% of it, then they're going to tap out and like, oh no, like, Noemi's a fantastic person. You need to learn from her. So, but thank you very much for sharing the time today. I really enjoyed it.
This is a really nice conversation. Thank you, Eric.